So in this last section, I'm going to go over several examples, and there's going to be less of these multi-step syntheses and more of these single-step syntheses, only because there are a lot of reactions in this chapter. So the first one we have here is R bond C double bond O bond OH going to R bond C double bond O bond Cl, turning the carboxylic acid into the acid chloride. This one you just straight up have to memorize. This is thionyl chloride, SOCl2, that's going to cause this reaction to go. Next one, we have this molecule plus something in the presence of a base gives us this molecule and their carboxylate, which is because it's in the presence of a base. So we need to recognize what is this. Well, this molecule is an anhydride. We have the oxygen in the middle and the two carbonyl groups outside of it. And over here, we have an amide. Well, what do we need to do? We need the nitrogen-containing group to attack here, and then this is the leaving group. So how are we going to do that? Well, in this case, we want to add NH2CH3. We're going to lose one of those H's through the reaction mechanism because when this attacks, it'll then be positively charged and it'll lose one of these H's. But you can see here, we can add this group, methylamine, to here and form the amide. Next one, we have something plus something yields H3O plus and this molecule here. Well, what we need to decide is, well, what is the functional group of this molecule? We have C double bond O R. This is an ester. So we have an ester here. This is a Fischer esterification. So when we do a Fischer esterification, this part is the carboxylic acid. And this part is the alcohol, HOCH2CH3. So we have ethanol and, cyclopentanoic acid, if you will, reacting together in order to form this. All right, let's look at the next one. We have an acid chloride forming an anhydride. So we basically need this group to attack here and get the Cl to leave. Well, what is that? That's the carboxylate. All right, don't necessarily need the counter ion, but C double bond O bond CH3. If we take the carboxylate and the acid chloride, we can make the anhydride. This is an interesting case. We have CH3, C double bond O CH2, CH3. We have an ester, and we somehow make two ethanols. It's just a coincidence, because if you look, CH3, if we put two H's on here and make this an OH, that gives us an ethanol. And the leaving group also happens to make ethanol. This is a reduction. This is lithium aluminum hydride reduction of an ester, as we looked at in a previous section. All right, let's look at the next two. Here we have an ester in the presence of NaOH and water. This is a base hydrolysis of an ester. This is a saponification. So it's going to break this thing. It's going to break it into the carboxylic acid and the alcohol. This is exactly the opposite of a Fischer esterification. It's essentially the opposite of a Fischer esterification, except it's happening at a base. So here we have CH3, C double bond O minus. And you can put Na plus there if you prefer, because it is NaOH. Remember, we can't get the whole carboxylic acid. We have to get the carboxylate because we have a base. The other molecule is HOCH2, CH3, which is your leaving group, is this one right here. Another one, similar. We have an amide in the presence of an acid, so an acid hydrolysis. In this case, because it's an acid hydrolysis, this is our carboxylic acid, and it stays as a carboxylic acid. How do we know it stays as a carboxylic acid? Because it's in acid. Remember, first step protonation, then water attacks, then NH3 leaves. But remember, you can't get NH3 in solution. Instead, it's NH4 plus that you're going to get in solution. Why? Because ammonia, NH3, is a base. Bases in the presence of acids become protonated. So we need to remember our acid-base chemistry when we're looking at these hydrolysis type reactions. All right, last two, they're similar, they're multi-step. Here we have two different reactions to form a carboxylic acid into this alcohol and a carboxylic acid into this ketone. But notice, this one has 2 carbons, this one has 4 carbons, this one has 2 carbons, this one has 3 carbons. So we need to both add carbons and we need to change the functional group from a carboxylic acid to an alcohol. Grignard comes to mind as a good way to add carbons. But remember, Grignards don't work in the presence of carboxylic acids because this acidic proton will essentially deactivate the Grignard. The Grignard will just grab that proton and then you'll end up with an alkane or a benzene if it's a phenyl type product, but in this case you would end up with methane. So that wouldn't work. So we need to turn this into an acid chloride. How do we do that? SOCl2. We then get CH3, C double bond O, bond Cl. And if I didn't mention, these are 2-step processes, as you've seen in other sections like this. We now want to convert it to this molecule right here. Well, in this case, we can do the Grignard. 2CH3 MgBr in the presence of usually ether, followed by H3O+. All right, so in this case, we can get these two to attack. Remember, after the first one attacks and this leaves, we can't stop at the ketone. We go all the way to the alcohol because the ketone is susceptible to attack by the Grignard reagent as well. Let's look at the next case. In the next case, we want to stop at the ketone. So this is very similar, and I'm doing these next to each other on purpose. All right, so here we want to stop at the ketone. This time, I'm going to make the acid bromide using PBr3. All right, doesn't matter. You could use SOCl2 too if you like. All right, so CH3, C double bond O, bond Br. How do I get it to stop? This is one you have to memorize. I guess you have to memorize all of them, but you know, it's one that's a little bit less straightforward. So we're going to use CH3, 2, CuLi. These diorganocopper lithium reagents will allow it to stop at the ketone. This isn't strong enough to react again with the ketone, but it is strong enough to react with the acid bromide in this case, or the acid chloride in the other case. It doesn't matter. These can be used interchangeably. So there's a lot of reactions in this chapter. It's really important to practice with them, and as I've said many times previous in these videos, it's really important that you write these things out. You will learn them faster if you write them down. All right, so that is basically that, and we'll move on to the next chapter.